end of the meetup. Thank you.
Next speaker. This is for you.
Entonces,
No.
llama
Que
de
ya
otro.
tienes, sí.
Ok.
¿Y quieres hacer la presentación?
Okay.
Okay. Okay.
Hello, everyone. My name is Miguel. I'm part of the Advanced Analytics and Algorithmic Trading team in Global Markets in BBVA. And today I would like to explain a whole project in KX that we have deployed. We currently have KX as our vector database for the FX trading desk. And we are making several projects. We are ingesting a lot of data. And today I will explain one of the projects that we would like to do in the future with simulated data. Okay, so yeah, the idea with today's presentation is so you get a full idea of how we have a business problem, and then we have a platform that is efficient in time series, and then we also have a statistical model that tries to solve this. And then we are bringing this and giving these results to using the KDB views to the trading desk or to any other team within BBVA. So the idea, as I said, is to have to explain the three nodes of our today's presentation is the platform, KX, the business problem, and the statistical model. Okay, I will start with the business model. Okay, so let's say we have a trading desk, and then basically when a trader gets one RFQ, which is basically a trade from a client, then the market of the asset, it moves from time to time. So basically what we do is compute a formula which is comparing the market mid price versus the trade price, and we just normalize this and we get how much you would get for a specific trade at a certain moment. So the idea is to get this flow value. This is what we call flow value for different trades, and then we try to accumulate this data for different trades for different clients. So in general, what we get is how good is the flow value of a specific client. So what our business problem is trying to I mean, the request from the trading is, okay, can we characterize clients? Can we say, okay, we have a specific clients doing this kind of flow and others another kind of flow? So this is what we are going to solve with a statistical model, okay, which is basically a model fitting, okay? In our statistical model, what we have done is we have characterized a function which is basically a decay with exponential function. Okay, and then the idea is to minimize the difference between our formula, which is the exponential, versus the market data, which is the flow value having all the traits of the customers. We have done using gradient descent updates, okay, which basically we have a learning rate that computes the gradients for the different three variables that are in the exponential, the k, the lambda, and the intercept, the b. And then we compute these gradients, and then we wait until we iterate until there is a conversion, until the step is very, very small, and then we have a solution, an approximate solution. Once we have the convergence, then we will have an estimate for our error, our sigma. Okay. And in the end, the other thing that I would like to get from you is the different parts that we have in KX. In this case, KX Insights Enterprise, okay, which is the platform that we are using. We have the Scratchpad, Visual Studio Code, the pipelines, and finally, in order to visualize the data, the final data that we have is the views. Okay. So now I will go into the demo. I will start with the Scratchpad. So, okay, so this is basically KX Insights. I'm not sure. So we have the queries, okay, which is the Scratchpad. This is a place where we can just query data. We can query all the database that we have. I'm going to query the assembly that I created for today's demo. I will try to I'm going to close this. Just, sorry, in order to, so I created this very simple code, okay, that we are basically just generating a random distribution, a random normal, a normal distribution from random data, okay, and I'm gonna show you how we do this in the Scratchpad. So basically, in the Scratchpad, we can query the data on this side, and then we can just query. And if we run it, we get a table like this one, okay. And then on this side, well, basically what I did is I'm gonna show you a little bit more the code. So I created this random distribution, and then I converted to a histogram just by grouping on bin sizes of 0.1. Okay. So the good thing about this is that we just go to the visuals, and then once we have the visuals, then we can apply different styles for the chart on this side. And I think the most efficient way to do this is with the format. I think there is a way right here. This one. Well, I don't find it right now. That's the demo effect, I guess. But basically on this side, and then we can plot easily the random distribution. Here, the bubble, instead of this, we do this one, okay? And on the x-axis, we have the key values, okay? And then on this side, we can plot we can play a little bit with the visualization setup, and then you can plot easily these things. Okay. The other let's say environment that we have on KX Studio Code that I showed a little bit before, in which basically, this is Visual Studio Code. It's connected to our database, okay, doing online. So basically, I'm not bringing the data to my laptop on this side. This is important for protection data issues at BBVA. But basically, what we do here, we connect to the Scratchpad. Basically, we're connecting to the BBVA to the BBVA Insights.com BBVA. Okay, and then we can just query the data and have and queryable data, and then but we still have all the tools used by Visual Studio Code. Okay. Okay, so I will. So basically, the first one is simulating data, getting the normal distributions. Then, basically, what my code is just generalize the data for end customers. Okay, with this function, we generate the RFQs, follow the exponential formula that I showed before. And then we do this for general for different RFQs. Okay. And then once we have this, we can create a table per customer. Okay, with the generation of the RFQs, and then we iterate over different customers, and then finally we have a table with all. Let's see if I'm connected. 1 second. Okay, I think I'm signing in. Okay, so it's still executing. Yeah. So this is the table that I would get. I have different customers and different RFQs IDs. And then, so I get, for each RFQ, I get different timestamps. Okay, this is at the moment that the deal was closed, time 0. And then I get the price with the formula that I computed, that I showed before, the normalized formula of the flow value for different timestamps. Okay. So in this case, I have generated until the 12 first seconds every 0.1 second. Okay. So I have my table in this way. And then what I'm going to do now is to run the algorithm, the gradient descent algorithm. The gradient descent algorithm is basically what we are doing is having a method for the exponential least squares. Okay. And what I'm doing here is scanning over all iterations and updating the parameters with the loss and grad, and updating each with the learning rate that I showed before. Okay, so the code is as simple as this. So, and these are the formulas of the different gradients, the different derivatives of the k, the lambda, and the b, which are the 3 parameters that I'm trying to learn. And then I get an output from a result from the fitting the exponential least squares. Okay, I can run it for different iterations, and then I can also add an initial parameters and a tolerance. Okay, for the convergence. Finally, I have the residuals, which is basically the difference of the fitted model and the true data that is behind. And what I'm doing in the end is just appending all this data for the different customers. So I'm learning a lambda, a k, and a sigma for each customer. Okay. So I'm running this estimation of the customer params for each of them. And in the end, once I have this, so I can recreate the function that I was looking for. So I have an average prediction of my model, and then I can create the lower confidence interval and the upper confidence interval with the error, which is the sigma. And then finally, I'm just creating a final table with all the data. I have the simulated data that I had from the beginning. I have the parameters that I have learned, and I also recreated like the average values that I have created. Okay. So once I have all my code, what I do is I take my code and I put it in production in KX. Okay, in order to do this, I go to the pipelines. Okay, and in the pipelines, I have well, first of all, I need to create a database, which is an assembly that I should stop working now. I get it twice just in case. So first of all, I create a database. A database is so it's like a specific, let's say, like space that I reserve for my table, and inside this database I also create I can have different tables. Okay, I have defined the schema of my table here. I define the primary keys, and I also the partitions and so on. And I reserve the memory for my table and all the pipelines that I can run. And once I have created the database, I created a pipeline. Okay, the pipeline that I have in my case is very simple. I just created an expression that has all my code that I pasted here. Okay, so this is all the code that you have seen before in Visual Studio Code, and at the end I just output the final table. Okay, I need to add a parameter for the partition key, and I only added 2 nodes. The first one defining the expression, and the second one, which is KDB Insights, the database writer, okay? That is selecting my database, the one I created before, and the flow value characterization table, okay? So once I created this, I've deployed my pipeline, and once the pipeline is deployed, my table is already running in the database. So now I can go to the views part, okay, which is the last one that is going to allow us. It's going to allow us analyze our results, okay. So first of all, I've created a drop down in which I can select the different customers ID, okay. So I've run my pipelines for different customers, and as you can see here, so in this first table, I have the customer ID, the time, which is the different times of the flow value, the number of RFQs for each of them, okay, and the average flow value at that time, okay. In this chart, let's see if in this chart, you can see the different customer IDs for the flow value at inception. So this is the moment that the deal was closed. And then we can see here, each of them has a decay of the flow value. And then, sorry. So, yeah, so, I mean, from until this point, I'm still not running my model. I'm just plotting the data of the simulated RFQs, okay? And this is for the different RFQs, and this is on a customer level. And then once I've run my model, I can get the parameters. So I can compare how different is the parameter B, which is the intercept, the true one versus the learned one, let's say. Okay, and then I also have the lambda, the k, and the sigma. Okay, and then also for each of the customers, I can plot how good I was doing. Okay, like plotting the error, which is basically the difference between the sigma estimated and the true sigma. Okay, and in the end, what I've plotted is the flow value comparing the average average flow value, okay, and the true flow value. So I think if I filter just one random customer, then we can see the last chart a little bit easier. So yeah, in this case, so we have an average flow value that is this way, okay, and in case one that learns this way, okay. So yep. So this is basically the project that I wanted to tell you. It's important. So maybe you're wondering, I mean, why is it important, this like measuring flow value? And like, so the good thing about this is that we are recreating the flow value of a customer from what is basically a lot of data points, and then we can just cluster them in three different parameters. No? So this is very important, for instance, as for clustering customers. This way we can say, okay, we have customers that have a lambda similar to another lambda to be between each other, and then we can cluster, and that can help a lot in the hedging models, or just for doing a better pricing for the customers. Okay. So let me come back to the. Let me come back to the presentation. Okay. Yep. So just a wrap up, I would like to go a little bit of where I have gone through. I've explained the business problem, okay, which is basically flow value and how this helps characterizing the. We went on explaining the statistical model, okay, in this case using a solution of a gradient descent, and finally we went through all main parts of KX Insights Enterprise. Okay. So that's all. Thank you very much.
Okay, any question? Manuel?
Thanks, Miguel. Very good presentation. What roughly, how long did it take you to build this project? I mean, regarding that you already have some experience on.
I think so. I've been programming in Q like 2 years more or less. Okay, so I'm not like an expert like Manuel or other people that really know how to code in Q. So like programming efficiently, that's what take me most of the time. That was like 4 or 5 hours, let's say, yeah, on 3 different days. And then building the dashboards and the data, that took me like 2 or 3 more hours, let's say. Yeah, just running. So in total, I would say 8 hours. Yeah. Saying that this is one of the first time that I do like consistently one project from beginning until the end, like focused, let's say, because then I have other projects, but then you're waiting for data, and then you develop one part, and then you wait 2 months, and then you develop the other part. But this time I was like focused, and that's 8 hours, let's say one. Okay. If you have all the data and everything ready, I think 1-2 days it can be done easily.
And you use Visual Studio. Have you tried the integration with Copilot, GitHub Copilot, and see if it works with Q? What is your feedback, or GPT? Does it help?
I haven't tried. I've tried coding with ChatGPT and it doesn't work that well. Well, it provides solutions. But I don't think they are efficient most of the time. And then yeah, many times the syntax is not good. Concretely with Copilot, I haven't tried.
And final question, I mean, you build this with Q, would you have done it with Python? Because now you have also capabilities in Python in Insights.
Yeah, that would be another option I could have tried, but I didn't in this case.
But are you feeling like more comfortable with Q now, so to prefer it?
Yeah, also I thought it was like a good time to get a little bit of hands-on.
Okay, thank you.
Yeah.
Thank you very much for your presentation.
Thank you.
A great, front to back end project, and I'm sure it was a really good learning experience, working from project start to project end. I'm really interested in your learning experience. So you mentioned you've been developing in Q KDB Plus for 3 years. Could you talk us a little bit through your journey and how you learned and what resources you used? We'd be very interested in hearing about that. And then maybe a follow-on question is your experience with Insights Enterprise. You may know it's one of our newer products at KX, and we're very interested in hearing user feedback and bringing that to, in the KX, bringing it back to our product and engineering team. So 2 questions. 1, your learning experience and learning Q in general, and 2, your experience with Insights Enterprise as a product.
Yeah. So learning Q, the first part, I would say, was most of the code that I was doing QSQL, which is basically trying to query data and then updating columns, and then just most of the tasks that I had were data preprocessing, and then you just write some joins, and then just I mean, you just try until you get it. Basically, you are not aware of the whole tools that you have in terms of the programming language, and then you just use those that are more related to SQL or to Python. No? That's been probably the first year and a half. Then it's true that we did a course of 4 days, the whole team, and then there you start to learn what is efficient and what is not efficient in Q. And then we start with the iterators and all this, the scan, the over, all this stuff that it's actually probably what is making the code more efficient. No? And that's the part that I'm trying to learn now and putting focus on that part. That's why I say I'm not like an expert on Q in that sense, because I'm not still very confident with the use of those tools. And then related to KX Insights, so I think in terms of interface, it's improving a lot. And then we also get like every new version there's an update, and there are things that are better. But yeah, I still think that, I mean, we are also very used to coding in notebooks, Jupyter notebooks, and then going from Jupyter notebooks to this like Visual Studio Code or Scratchpad and switching, that's getting a little bit tough. Yeah, that's getting it's a hard thing for us in that sense. But yeah, I think I mean the pipelines, I was surprised this time the pipelines worked quite well. Of course, you need to know specific things, and we would need some help from your part in that sense, because there are probably some nuances that we still don't have control of. But in general, I think it's improving.
Thank you very much.
So Miguel, thank you very much. Excellent presentation. Thank you.
Thank you.
So this is actually a question for Juan. So Juan, for you, can we come back? I'd like to come back, and I think a couple of things. So number one, to show people the KX Academy. So that is our university online on the kx.com website. So all of you can get access to it. We want to get KDB Q into university. So tell your friends, you know, you can all get access, you can all do the courses, and you'll all get certified free of charge. So that'd be a great thing to do. And then another way to get familiar with Q is through PyKX. So PyKX is our Python operability, which we have a way of actually writing Python that familiar with Q through Python, and then, you know, and that's another way to get familiar with it if you want to play with the actual Q code. But if we can come back, please.
Okay, yes, sure. KX Academy is great. I mean, it's a great platform. It's one of my favorite platforms for online courses, and I mean, the setup and the infrastructure and all the things I copied from my own course on declarative programming at the university. So it is great. In fact, when we did this training for BBVA last year or 2 years ago, I think it was 2 years ago, we had some difficulties for, okay, it is everything in KX Academy. So what we did was to set up a course on problem solving, because all the basic stuff was on KX Academy. And so it was a great support for us. And I think this is great. Yes, at the university, I have 2 students here that are doing their master thesis on KDB+, and it is very recommendable. Also, the technology for investigating and researching on temporal time series databases and this kind of stuff is great. So, thank you very much, Miguel, and our next speaker, Christian from Aula Computing. And yes, I forgot to say that KX is sponsoring some drinks after the event. Okay, we will be at the Iris Pub around the corner, so you are all invited by KX. Okay, muy importante, aviso muy importante.
So thank you very much. Okay.
Okay. Okay. Okay. So well. Now? Okay, yeah, better. Okay. So, hello, thank you for coming. I'm Cristian Aberturas. So, I'm going to talk about pairs trading, a financial strategy implemented in KDB Plus using the tick architecture, okay? But first, let me introduce myself. So, I'm a software developer working for Habla Computing, okay? So, well, Habla is a boutique consultancy focused in functional programming. We organize several meetups, for example, this one is about KDB Plus and Q, among others. For example, the Spark meetup or the Scala meetup, also here in Madrid. We have also a blog where we write about things that we find interesting, for example, the topic of this talk. And we also participate in different software conferences, okay? So now, let's see. So what is the aim of this talk? Well, I want to show you how simple and easy is to implement a financial strategy. In this case, I've selected pairs trading within the tick architecture in KDB Plus. So that's my purpose. So in order to do this, I prepared this outline, so divided in two blocks. So the first block, we're going to review the tick architecture. So that's what I'm going to do at first. Then we're going to review, we're going to try to understand a core concept that we need to understand to understand the whole architecture. Okay, that's the IPC, the inter-process communications, and finally we will see a naive tick architecture working in real time. And in the second block, we will see pair trading. So first, we will need to understand what is pair trading. Then we will see an implementation in KDB Plus, and we'll see everything works. Okay, so let's start. The tick architecture. Well, I took this graph from a blog from Alexander Unterreiner, DEFCON Q. This is a pretty good blog, so I recommend you. So here in this graph, we see some boxes and some arrows. So each box is a KDB process, and each arrow is a connection between a process and to another. So, well, the tick architecture was developed to handle high-frequency data. So that's one of the reasons, one of the many reasons that why financial institutions use KDB Plus all around the world. Okay, so we follow the data. At the left, we had two processes: the data feed and the feed handler, that are responsible for gathering the data from sensors and then trying to adapt that data to something that KDB understands. Okay, those two processes are not considered into the tick architecture because it has to be about sensors or brokers that are external processes about the tick architecture. But that data is sent to the ticker plan. The ticker plan is the first process of the tick architecture and is the most important one because it has to receive and handle the data up to date, and then it has to manage every subscription. So every subscription is every process that is connected to the ticker plan. Okay. So for example, one subscription, the real-time database, is just a process that is going to be connected to a ticker plan. So it's going to receive data and it's going to store that data in memory. So you can query from outside to the real-time database to query data in real time. And at the end of the day, that data is going to be sent to an on-disk file system and it's going to be stored there. So there is a process that is connected to that on-disk file system. So you can query your historical data over this process. So that's one example of a subscriber, but we can have any generic subscriber. That's what we call real-time subscriber. That is connected to the ticker plan and do something with data, something, for example, our use case. And finally, the ticker plan log file is a special thing. It's just a place where a file where we are going to store that data, the data that the ticker plan is going to be received. And it's just to, if we want to restart the tick architecture, we can replay this file so we can restart the real-time database without problem. Okay. So now we have seen more or less the ticket architecture. Let's see how these connections are made between processes. Okay. So I have a Jupyter notebook. Okay. So good. So I have two notebooks, the client and server. So our purpose is to connect the client to the server and send actions from the client to the server. So first of all, let's start with the server. Here, we just have to tell the server to start listening incoming requests. How can we do that? Well, /p and setting the port number. For example, in this case, 6001, okay? Very good. And just I'm going to load some data with this code and a function, so we can play with something, okay? So let's go to the client, to the most important interesting thing. First of all, we have to open a connection handle, no? A way to connect to the server. Well, we have this keyword hopen. So here we have to pass the path, no? So we will do something like this. So localhost and the port number, so 6001, and we will store this in a variable h. Okay, very good. But we really like concise code, so we can omit this, and it still works. Okay. So we have our connection handle. So now we can send actions. So for example, let's execute this in the server. So 1 + 1. Okay. So here we're getting the 2, but this message is being evaluated in the server, not in our process. Clearly, we can see, for example, we can get the data that we have stored in the server by doing this. Oh, sorry. Let me. So here, soon. Okay, better. So we can get the data by doing this. So just passing the handle to get the info from T. Okay, just to know that we just get T from this process, T doesn't exist in this process. Okay. Okay, so let's get the T from the server and save this in a variable T1. Okay, but these kind of messages, just evaluating strings, is not very reliable and it's not very scalable. So we have another way to do this, just sending a list that we call a parse tree. So for example, we have a function defined in the server called f, as you can remember. So we can say, okay, evaluate the function f with the arguments T1. So this syntax also works and is quite more scalable. So here we have our result in our server. So that's it. So as final, just close the connection. Don't forget it. Okay, very important. So that's how these connections are made in KDB+. So well, let's go back to our presentation. Okay, so we have seen connections. We have seen more or less what is the role of each process. So let's see how can we implement, for example, the most important processes of this ticket architecture, no, of this naive, the fee handler, the ticket plan, and the and subscriber. So let's start with the most important one, the ticket plan. Okay, so this ticket plan. So as you can see, it's quite intimidating because it's complex. Okay, it's normal. This code is not something that you come up from scratch. Actually, this comes from the official KX repository of the ticket architecture. So that's good. And it's complex because it's necessary to be complex. I mean, it has to manage a lot of functionalities. It has to receive data up to date. It has to store the raw data in a log file, and it has to manage the subscription. Even though we have just an implementation in 25 lines, or even 20 lines, less than 25 lines. So very, very concise. And in most of our applications, we are not going to need to modify this. So very good. So okay. So we will have to understand this, but at least we have this, and we don't need to change it. Okay. So we can focus on the rest of the processes, the feed handler and the subscriber. So let's go back to the Jupyter notebook. Okay, let's start with the subscriber. So first of all, we're going to load a ticket plan utility library. Okay, some functions that we're going to need. So /l and here the path of our file that we want to load. In this case, tick.u.q. Very good. Okay, sorry. So now let's create an schema, just an empty table. Very good. Just to save the data in somewhere. Finally, and the most important thing, the ticket plan, what it's going to do really is to send the data something like this. So the ticket plan is going to have a handle to our process, and it's going to call a function UPD with a table name, code, and some data. So important thing, you are asking, we need to define a UPD in our process, because if not, this is going to break. I mean, if not, doesn't make sense. So let's declare something like that. So our UPD has to receive a table name and some data. So what can we do? Well, just insert the data. Okay, so insert over table name and data. So we are making use of the keyword insert that we have in Q to declare our function UPD. But well, again, we like a very concise solution. So instead of doing this, we can just do this. This is what we call a tacit definition. We declare a function without telling which are the arguments. Okay. And as a final steps, two things. So we have to connect to the ticket plan to subscribe, because if we don't connect, the ticket plan doesn't know that we want to get that data. So let's open a connection. Open, we've seen before. And let's tell the ticket plan that we want to subscribe to a table code. So in order to do this, I'm going to tell the ticket plan with this function, with .u.sub from the ticket plan utility library. Okay, so we have to pass the table name, and we have to tell which symbols do we want to subscribe. In this case, we want to subscribe to every symbol, so empty symbol. Okay, so we are subscribed. So let's I don't know what is happening. I mean, I don't know. My laptop is okay. Well, I'm going to okay. Okay, so let's declare a field handler. Well, field handler is even easier. We just have to open a connection to the ticket plan to send the data with something like this. And just this function, what it's going to do is to send random data. In this case, random. In reality, in production, we will have sensors or a broker or something. In this case, random data is valid for us. So just send random data. Very good. So if everything is good, we can go. Oh, I think I didn't. Okay. Now I didn't declare the UPD, so it wasn't working. So here we're having data in real time, updated. Okay. So it's working. Okay, not bad. So well, let's go back to our presentation. So well, we have seen the ticket architecture. So let's go back to the pair trading. Okay, what is pair trading? Well, I've prepared a simple video. Okay, so here we have a time series. In the x-axis the time, in the y-axis the price. So in blue we have an asset, a price of an asset A, and in red we have an asset of a price, a price of an asset B. Okay. Well, as you can see, the prices at the beginning of the time looks very, very similar. But at some point, the asset B starts diverging from asset A. And at the end, the behavior reverts back. So pair trading is a strategy that just try to, okay, so we have two assets that behaves very, very similar historically. If at some point we see a divergence, we could expect to that behavior to revert back in some point. So if we see a divergence, we have what we call a trading opportunity. No, so here we could be short and long. So we would have earned money in this case, no, because the behavior revert back. Okay, so the idea I think is simple. So let's see some equation to understand what we have to implement. Okay, so I have two pair of assets. So I have to find two pair of assets that satisfies this. So Y equals alpha plus beta times x. Okay, alpha and beta, two real values. So we have to find this. Okay, but instead of almost equals, I want an equals, no? So we can translate those equation in this one. So we can have y equals alpha plus beta times x plus something, plus an error, plus what we call a spread. So what we have to do is to find an alpha and beta that that allow us to get an epsilon and a spread that is very stable and very reduced over the time. If we have that, we can calculate that spread in real time. And if we see if this spread is different and higher or lower than the ones that we get in the past, we would say that we have a trading opportunity. So pretty simple. And this explanation, I think, is good because we have a separated explanation in two things. And that two things are the two things that we have to do to implement this. So first, find the x and y that moves very similarly. That actually, I didn't say that when we have two pair of facets that satisfies this, we say that these pair of facets are co-integrated. Okay. So we have to find these two assets co-integrated, and then we have to fit alpha and beta. And on the other hand, we have to calculate in real time this spread. I think it's very easy. So let's go. So we have our ticket architecture. So I've extended it with three processes. First of all, the MS process. MS process is the model server that, as you can see, there's a pykx.q that is telling us that we are going to use Python. I will explain later why. But this model server, what has to do is to find the best co-integrated assets and fit the alpha and beta, get the best alpha and beta. And that information is going to be sent to the real-time pair trading indicator to calculate in real time the spreads. So once we have the spreads in real time, in this case, I'm going to plot it, but we could send some market orders, or we can do something. Okay. So let's go. Let's see how we can implement a model server in this tick architecture. Okay. I have here this notebook. So first of all, we have to gather historical data. We have seen several times how to do this. Just open a connection and send in a query. This code. And these two lines are just because we need to get every pair of assets, so the cross function. Okay, so we can execute this. Okay, now we have to check for every pair of assets if they are co-integrated or not, because we want some pair of assets that is co-integrated. Okay, so in order to do this, we could implement a function, a statistical function in Q. We could. Okay, sorry. So we could implement a statistical function in Q, but instead of doing that, why not? Why don't use a Python function from a library called Stots models? So it's going to be faster because I'm not going to waste time, and I think for this case it's good because we are not waste any time in real time. So how can we call a Python code from Q? Well, in order to do that, we should use pykx, the latest version of kx to use Python from Q. But I have a problem. As far as I know, I haven't found a kernel with Q and pykx. So what I have to do is to use the deprecated version of pykx, but it's the same syntax. So don't hesitate. So it's almost the same. So instead of loading pykx, that will do something like this. I'm going to load embed.py, that is p.q. And to import our function, I'm going to copy this. This is the function. I'm going to use .p.import. Okay. And I'm going to pass this. So this is the syntax. So if here I'm using embed.py, but if we will use pykx, difference would be something like this. So almost no difference. Okay, so this takes some time to load the entire library. Okay, so well, it's loaded. Okay, now we have to apply this function to our data, our Q data. So first of all, let's see how looks our data. Well, it looks like this. This is a kth table. So let's index. So let's, for example, get the prices for VFX, and now we have to index again to get the close price. Okay, well, we have to do this for 2 indices. So let's put here, for example, FG, for example, and let's call the function go. We have this. This is something that Q doesn't understand because this is a Python output. So just putting here as an empty symbol, we are telling Q to pass the Python output to Q. So this is the result. So now we have to do this, but instead for one pair of assets, for everyone. Well, I have this code to do it for me, and I also have imported a Python library to plot the results. So here we have the results. So this is the heat map. So here we can have a look. I will say that the most integrated pair of assets is root and stocks. Okay, pretty good. And finally, what I have here is just 3 pair of functions that is going to be very, very useful in our real-time period indicator, because with these functions, I have our alpha and beta calibrated using some Q logic. Okay. So I can go back and let's see how to implement the real-time pair trading indicator. Okay, so we had two things to do. First of all, we have to get the most integrated pair of assets from the model server. Very easy, just sending a query to the model server. So this MS is a handle connection to the model server. So here I have the most integrated assets. The second thing is to subscribe to the ticker plan and tell the ticker plan they want to get the data from code, just these 2 assets, only these 2 assets, very easy. And the other thing was is to calculate these spreads. So if you can remember, the other time we declared UPD as just insert. Yeah, we were just inserting the data. In this case, I'm just post-processing a bit the data we're receiving, and I'm calculating the spread using this function that I got from the model server. And finally, I'm inserting that data into a table. So that's it. So this is how the full real-time pair trading indicator would like. So just 18 lines without, if you remove empty lines, they are just 15 lines plus 10 lines of the model server. We have something like 25 lines of implementation of a financial strategy. So very concise, very efficient, and I think very elegant as well. So a very good implementation, I think. So, okay, we are almost at the end. So let's see if everything works and we have something on the dashboard. So let's go here. Let's refresh this. Okay. Okay, and here we have it. So it's a very, very simple dashboard compared to the one that Miguel just showed you. But I think it's useful for the case. We are just showing how the prices for the 2 assets moves in this case, and here we see the spreads. Okay, so in blue. So here our model is telling us that it's a good moment because it's not within these yellow lines. So it's a good moment to trade. Well, we could review the model. We will review the fit to see if this fitting is good or not. But well, that's not the purpose of the talk. Okay. So that's it. So well, let's go back to the presentation to conclude. So well, as I said before, this talk is based on a blog that I co-wrote with Jesus Lopez and Oscar Niza, 2 colleagues of Habla. So thanks to them. So if you have some doubts, you can ask me in 2 minutes, or you can read the entire blog so that everything is explained deeper. I want also to recommend the KX Academy official course, as we have just mentioned before, because it's a very good resource to understand the tick architecture, also the tick architecture and also the Q language. And I also want to recommend the blog of Alexander Terreiner, Dev con Q, because it's also a good resource to understand the tick architecture and more advanced things, okay, in Q. So to conclude, we have just seen that the tick architecture is very, very powerful and is really easy to adapt to our necessities, our needs, because we wanted to implement a financial strategy and just took 25 lines, and I think it was very, very straightforward from the naive TIC architecture. And also, as almost every talk here in this meetup, we see that Q syntax provides a very reduced way to implement our ideas. So it's a conclusion that is repeated in every talk that is given here. And so as a final note, I want to encourage you to implement your solutions to your problems using Q, because it's a very elegant and efficient way to solve your problems. So that's all. Thank you for listening.
Thank you very much. Any question from the audience?
How much money have you made, Christian?
I haven't tested this in reality, sorry.
No, it was a great presentation. Thanks very much. Do you have any other ideas? It sounds like you might have a few pet projects or any other.
I mean, wherever. I mean, you can implement whatever financial model that you come up with. So the good thing about TIC architecture is that you don't have to think about the TIC architecture. So you have to think about the model. So you can spend your time thinking in the model. That I think that makes sense. I mean, the complex thing I think is the math and the financial model, not the TIC architecture. So that's a thing that I think is very important.
Well, just to build on that theme, Finbar, do you want to set us up a crypto business together? That's great.
So crypto, sorry?
Yeah, crypto trading. This would be brilliant.
So no, I haven't tested, but maybe you can implement it. And I mean, in TIC architecture, you don't have any latency, almost any latency, or even if you work with a lot of data, you can do some improvements to solve those problems. So you can implement it. I encourage you to do it.
It's all in the spread, so very impressive. So well done, thank you.
Thank you.
Thanks, Christian. Very good presentation. One question: what is your experience in terms of actually available code in Q in the web? So, for instance, statistical libraries or even already pre-coded trading strategies, because pairs trading is a typical strategy. I'm not aware of there is an implementation apart from yours that you had in your blog, but I don't know. What is your experience?
To be honest, there's not a lot of functionalities open source. So you have two options: or use Python, or you try to implement yourself. So there are some libraries, I think ML about the machine learning and some about statistical, but they are very naive. And if you start to doing something more complex, you need or Python or start implement yourself.
Okay, thank you. And one question actually for the case guys. I mean, we see the Jupyter all the time. I know you have. I mean, there is the Q kernels, but for the insights, if I want, would it be possible to have something like this? I have a local Jupyter notebook, local. I don't mean it a server, a local that connects to insights, and I just can query from the cells as I do it, sort of like scratchpad replication. But I mean, it's like you see, it's a permanent, sort of implicit suggestion. Like people like to work with notebooks, and
I mean, that's the feedback we want to hear that from the community. That's the feedback that's the kind of feedback we want from the end users, and that's the kind of feedback that our product management need to hear. So they need to hear it firsthand from you guys, not from me. So we do welcome your input into the product roadmap. So thank you. No, really impressed. Really impressed.
Thank you.
Thank you.
Okay, any question? Any further question? No question? No more question? We can just do the raffle.
That's raffle. Really high tech. This is so high tech.
Okay.
We did actually come up with an idea of doing a high-tech solution.
Should be more. Sí, se puede descargar, es una aplicación. Sí, sí. No, lo he cogido, no, me descargué en su momento en CSV y lo leo, lo simulo en real time. Pero me los leí, los descargué de, no sé. Sí. Claro, sí, tiene una aplicación, te la puedes descargar. Y además, yo creo que está actualizada. Oh, hostia. Están aquí escuchando. Bueno, ahora. No lo abierto. No, es para mí. Y lo rompe, es para mí. Esa vieja forma que ya vas a tener más probabilidad en los dos.
Yeah, good luck. No, you're it's your event, well.
Okay, so the winner is. Can I see if that's mine?
Atención.
The number is number 8.
Number 8.
Number 8.
Number 8, come on up.
That's an 8, that is. Thank you.
Está guapo.
I don't know, but we drink beer at KX. If you drink beer, come join us for a bit.
Of course.
You're welcome.